All right, AP, let's look at a sample problem or a few sample problems using significant figures in mathematical operations. Now, this is going to be a big deal for you. This is going to be a huge indicator of your ability throughout the rest of the course, because we're going to be doing, obviously, a lot of calculations throughout this course. You're going to be doing a lot of calculations on the AP exam. And one of the things that you're going to have to always take into consideration is the number of significant figures with which you're going to report your answer. Why? Because on the AP exam, there's always at least 1 point on every free response question that you're going to be awarded or not awarded based on your ability to use appropriate number of significant figures in recording your response. Some free response questions will be worth 4 points. Some of them will be worth as much as 10 points. But there's always going to be one of those points available for an appropriate number of significant figures. And so we need to get this down cold pat right now. Now, two of these sample problems are going to be pretty simple. Just seeing if you can use the significant figure rules for multiplication and division problem, and then an addition and subtraction problem. But then we're actually going to do a whole calculation. Okay, we're going to throw stuff into an equation. We're going to solve an equation, and then based on whatever number we get, we're going to try to evaluate how many significant figures we're going to report that response with, or that answer with. So let's get started. Carry out the following mathematical operations and give each result with the correct number of significant figures. A, we have 1.50 times 10 to the negative third. It's a number in scientific notation, so all those are significant. Divided by 6.135. B, we have 21 minus 13.8. And for C is the big long equation. We're actually going to be using this equation here. And by the way, this stuff that I'm about to read and this equation is actually going to be something that we go over in a chapter coming up here pretty darn soon. But because we haven't gone over it, we're not going to worry about units. Okay? The units that go along with these values that I'm going to give you, those will be important. But because right now we're practicing our significant figures, we're not going to worry about units right now. So C, as part of a lab assignment to determine the value of the gas constant, R, a student measured the pressure, P, volume, V, and temperature, T, for a sample of gas, where R is equal to PV divided by T. This is the equation that we're going to use right here. Again, you don't have to understand why this is the way it is. Just know that this is the equation we're going to use. Plug and chug. So the following values were obtained. Pressure is equal to 2.560. Temperature is 275.15. And volume is 8.8. And again, gases will be discussed in detail in Chapter 5. So we're not going to be concerned about units at this time. We're just looking at the quantities. Calculate R to the correct number of significant figures. Go ahead and press pause. Generate a result, an answer for each of these. Oh, my solution's snuck up there. Don't look. Press pause if you need to, because here come the solutions. All right, so A, the result is 1.71 times 10 to the negative fourth, which has 3 significant figures, because the term with the least precision, which was the number in significant figures, scientific notation rather, had 3 significant figures. So that was the limiting factor there. B, the result is 7 with no decimal point. Because the number with the least number of decimal places was 21. It has no decimal places. So our answer can't have any decimal places. Even though the 13.8 had a decimal place, we don't get to use that amount of precision. So the answer that we record is 7. Now for C, the calculation that we're going to carry out has to do with gases. We're going to use the R is equal to PV divided by T. And we're going to plug in these numbers, the 2.560, the 8.8, and the 275.15. The correct procedure for obtaining the final result can be represented as follows. So we are going to multiply. Here we're going to multiply, then divide. So we're multiplying and dividing. And so we're going to use the multiplication and division rules, obviously, for determining the correct number of significant figures. The final result must be rounded to two significant figures because 8.8, which was the least precise measurement, has two significant figures. Now, to show the effects of rounding at intermediate steps, let's carry out these calculations step by step as follows. So, if we start with this first multiplication right here, low enough, yeah. We're going to start with this multiplication right here, the 2.560 multiplied by 8.8. We're going to get 22.528, but we need to round after this. Okay, and that's what I mean if we round at intermediate steps. This is an intermediate step. This is the first step that we've taken. If we round after this, we would round this number to 23 because it has two significant figures. We determined that we need two significant figures because of this 8.8 only having two significant figures. Then we'd proceed to the next calculation, which would be the 23 divided by 275.15. That's this calculation right here. And then we would get the 0.0835908. Notice that these two numbers are already different. These two numbers are already different. And so rounding at the end and rounding at intermediate steps can have a significant impact on the response that you get. That's what we're trying to point out here. So let's get down here at the bottom. Get straight. Get straight. Close enough. So rounded to two significant figures. Again, two significant figures because of the 23. The final result is 0.084, represented in scientific notation would be 8.4 times 10 to the negative 2. Note this number and this number. Notice how different they are. You notice how different they are. 8.4, 8.2. Those two numbers are very different, and those are our final responses for what R is. So, again, this one we rounded at the end. Okay, we rounded at the end. We just carried all this junk out, and then we, not rounded, I'm sorry. We considered significant figures at the end here. To generate this response, we considered significant figures at each intermediate step. So note that the intermediate rounding gives a significantly different result than that was obtained rounding only at the end. Again, we must re-emphasize that in your calculations, you should round only at the end. You, AP students, should only round at the end. However, because rounding is carried out at intermediate steps in this text, okay, in the textbook, always show the correct number of significant, we're always showing the correct number of significant figures. The answer given in the text may differ slightly from the one you obtained because you, as an AP student, are going to be rounding only at the end. Okay, so going through these sample problems, if you ever come up with a calculation that's a little bit different than what I show you, because again, I'm getting these sample problems actually from the book, just talking you through them. If I come up with a response that's slightly different, now it should be in the same ballpark. It shouldn't be radically different. But if it is a little bit different, that's why. The book, the text, is actually rounding at each intermediate step, whereas we want you, preparing for the AP exam, to just round at the end.